All right, guys, so real quickly, I'm going to go through the quiz that you took yesterday. I wanted you to take this, or I wanted to make this so that you could do a retake. There were a lot of issues with this quiz. I did curve it by 2 points, so I don't want you to panic too much, but we have a test on Friday, and this test is designed to help you boost your grade. So I'm only going to count it if your grade goes up or stays the same. Otherwise, I'm going to throw it out. So question 1. First, they want to know, is triangle ABC congruent to AED? So they're referring to these two triangles out here. Well, let's look at some of the things we have. We have a side congruent to a side. This side is congruent to this side, and this side is congruent to this side. A lot of you saw that. Now, ASS, that swear word, is not a congruence theorem. Our options are side, 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 angle, 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 side, and HL. Well, clearly it's not HL because we don't have any right angles. But what a lot of you missed is that if this is 7 and this is 7, this side is congruent to this side. So there are actually two answers to this. It is for sure yes, but you could have either proved it by side, angle, side, with side, angle, side, or look, all three of these are congruent to each other. So the two options were side, angle, side, and side, side, side. Number 2, what other information do you need in order to prove the triangle is congruent using the side, angle, side congruence? So side, angle, side requires two sides and the angle that is included in between. So we start off with BC is congruent to CD. Those are both sides. We can fill in that AC is congruent to itself because it's on both triangles. So we have a side. I know that our answer has to be an angle. Now, I don't need you to plug in the symbols when you plug it in online, but I'm just showing that it's going to be an angle. Well, in order to be side, angle, side, the angle has to be in between here. It needs to be this angle is congruent to this one. A lot of you said these ones out here, but that doesn't give us an included angle. So the answer is angle ACB and angle ACD. These angles right here that are formed at C. Now we can't say angle C here because there's more than one angle at that point. Are these triangles congruent? Justify your answer. We have a side congruent to a side, an angle congruent to an angle, but we have to fill in any extra information that we have. And I know that this piece in the middle is congruent to itself. So we have a side here and a side here. Two sides and an angle, so the only one it could possibly be is either HL, but there's no 90 degrees, or side, angle, side. So we check, is the angle included? Yes, it makes a sandwich here. So yes, side, angle, side. Now, are these guys congruent? So they just gave us some information. We have 5 and 5. So yeah, those are congruent sides. 16 and 16. So these are congruent sides again. And finally, I fill in that AC is congruent to itself. So yes, those are congruent because we have 3 sides congruent to 3 sides, side, side, side. Name the angle included by the sides PN and NM. PN, NM. What angle did I just form looking at those two angles? This one right here, so angle N. Now, which additional information does not allow you to conclude that triangle ABC is congruent to DEF? Well, let's fill in the given here. Angle A is congruent to angle D. Angle C is congruent to angle F. So some of you might be able to recognize just by glancing at these the one that is definitely not going to help us conclude, but I'll go through step by step. So if I knew that BC was congruent to EF, would that tell us? Yes, they'd be congruent by angle, angle, side. So it can't be A. When we get to B, we have, would angle B being congruent to angle E tell us that they were congruent? No, because angle, angle, angle is not a way to prove triangles congruent. That is not one of our things, so it is definitely B. We can check the other ones. If we knew that AC was congruent to DF, that would be angle, side, angle. And if it was AB congruent to DE, that would be angle, angle, side. So angle, angle, angle does not exist. All right. Can we conclude by the side angle side, the angle side, or angle side, or both that these are congruent? So to start, we have side, side, angle, angle. Well, let's fill in the given information or stuff that we can see happening in our triangles. We know that these two are going to be congruent because of vertical angles. All right, so angle, side. So is there a side angle side possibility? No, we couldn't add any sides in there. So I can also cancel out B. C is the answer because of angle, side. From the information, can you prove that triangle FDG is congruent to FDE? Well, as is, this is angle. So your first, you might try and say no at first, but remember we have to add in any information that we can see. We know that DF is congruent to DF. So yes, they are congruent. There are two options here. If I look at these, I have an angle, side, angle option. But if I use these here, I have an angle, side option. So either one of those will work. Which pair of triangles are congruent by angle, side, angle? Well, we have angle, side, angle here. So you might try and pick it, but is that the same here? No, this one will be angle, side. So it's not this one. Side, angle, side, angle, side. So it's not this one. Side, angle, side, angle, side. It's not this one. Angle, side, angle. Good. Angle, side, angle. Perfect. The answer is D. Which triangles are congruent by angle, side, angle? So you just have to drag the two. Well, first of all, look at this one. We only have one angle and we have two sides. There's nothing else I can add. They're not attached to anything, so it can't be this one. So you could pretty much eliminate it and go with those two, but let's check. Angle, side, angle, side, angle. So you would pick FGH, you drag it there, and CBA, drag it there. This is the last problem. Nope, two more problems. Name the theorem or postulate that lets you immediately conclude that these are congruent. So this one was a little tricky. For one, we have an angle congruent to an angle, but we need to remember that when we have a 90 degree here and it's forming a straight line, we can add the 90 degrees on the other side. So far we have two angles. Is there anything else we can add? Yes. I can fill in this reflexive property here. So since we have 90 degrees, you might start to question HL. So if I check that though, I only have one leg. I don't have any hypotenuses marked, so it's not HL. So I have two angles and a side, so it's definitely not that one. So now we're down to angle, side, and angle, side, angle. Angle, side. That side is not included in between, so it is angle, side. Finally, what additional information is needed to prove the following triangles are congruent by HL? So there's 3 steps to checking for HL. First, do we have 90 degree angles? Yes. Angle, they're 90 degrees. Do we have a hypotenuse? Do we have markings on the hypotenuse? Well, if I look across. No, I don't. So I know that I'm going to need some sort of hypotenuse marked. Do I have a leg? Yes, GH and TS. So I don't need to add that, but I have it, the leg. So which is the hypotenuse? Well, TU is a hypotenuse. So I'm going to drag that there. And I would need to know that it is congruent to FG. Drag that there. All right. So that is the quiz. If you have questions beyond this, please contact me before you complete the retake. This quiz shouldn't take very long. I'm not sure what happened here. I think there are just little things that might have been tricky and I didn't recognize that they were going to be tricky for you guys. So please let me know if you have any questions. I'll be happy to help. We have a test tomorrow, so contact me if you have any issues with that. Have a great day.